Alright, ladies and gentlemen, this is 055, graphing absolute value inequalities. Notes, your objective, you'll be able to graph an absolute value inequality. So looking here at problem number 1, our directions say graph each equation, or inequality here. On number 1, we say y is greater than the absolute value of x minus 3. Now to graph this equation, we have to remember how to graph absolute values. What we could do, we could first just type it into our calculator, into our y equals calculator, or we could just remember that to find the vertex, what we need to do, we do the opposite sign that's inside the parentheses here, or not parentheses, the absolute value bar. So x minus 3, well, the opposite of minus 3 is positive 3. And on the outside of the parentheses will tell us the up and down part of our vertex. Since it's plus 0, our vertex then is 3 comma 0. Just like what we did in the previous class with graphing absolute value equations. So 3 zeros right there. So we know that's our starting point, that's our vertex. Then we can plug in 4. 4 minus 3 gets you 1. The absolute value of 1 is 1. So our output then is at 1. So when x is 4, y is 1. Then we could put the number 5 in. 5 minus 3 is 2. The absolute value of 2 is 2 plus 0, which is 2. So when x is 5, y is 2. When we plug in 2 in for x, 2 minus 3 gets you negative 1. Absolute value of negative 1 is positive 1. So when x is 2, our output is 1. When we plug in 1, 1 minus 3 gets you a negative 2. The absolute value of negative 2 is 2. So when you plug in 1, you get 2. And we successfully graphed the absolute value equation. However, now we have to worry about the inequality part, which means do we have to shade up or shade down? Well, anytime the little inequality guy is eating a variable, that's saying y is greater than. So this is greater than the x minus 3 plus 0. So where are the numbers greater than on our graph? We have both numbers to the right and to the left. What I like to refer to, I always like referring to the y-axis because it's eating the y. So we're going to refer to the y-axis. If we look at our y-intercept, it's at 3. Where are the numbers that are greater than 3? Well, that would be 4, 5, 6. So I'm shading above. Those are numbers that are greater than. So on that side of the absolute value wall is where I got to shade. I'll use a better shading tool. Let's do this. So we're going to shade everything on that side. So that's greater than. So y is greater than the absolute value of x minus 3. Close absolute value, that's our answer. Alright, let's try another one. So looking at this, same story, we have to graph the absolute value equation and then also work with the inequality part. So we have y is less than the absolute value of x minus 1 minus 3. So to find that vertex part, find the vertex part, we know it's the opposite, so the opposite of minus 1 is positive 1, and then negative 3. So 1 to the right, 3 down. So we graph to 1 point. When we plug in 0, we're going to find out what our result is. So 0 minus 1 is 1. 1 minus 3 is negative 2. When we plug in negative 1, negative 1 minus 1 is negative 2. The absolute value of negative 2 is 2. 2 minus 3 gets you negative 1. So negative 1, negative 1. Then we plug in 2. 2 minus 1 is 1. Absolute value of 1 is 1. 1 minus 3 gets you negative 2. And then we plug in 3. So 3 minus 1 gets you 2. The absolute value of positive 2 is just positive 2, and positive 2 minus 3 gets you negative 1. So once again, you could just plug it right into your graphing calculator. And you can see it immediately too. You can bring up the table, plot all the coordinates on the table, instead of plugging them all individually into the calculator. So now there's our absolute value equation. Now we have to address the inequality part, which is the inequality in our equation. This says y is less than this absolute value equation. So this is less than. So when something's less than, we know we always went to the left in grammar school. But less than is really just below. Since we're talking about the y, we're referring to the y values. So we go to our y-intercept, which is negative 2 right here. So where are the numbers that are less than negative 2 on our number line that's up and down? Well, less than is the numbers that are less than negative 2 are negative 3, negative 4, negative 5, negative 6. So those numbers are the less than, so I'm going to shade that way. So it'll be on that side of the wall. So everything on that side of the wall gets shaded. So we're shading everything there. Now it also includes this side right here, because technically that is also on the same side of this red absolute line wall, absolute value line wall. So we're going to shade that too. Cool, that's our answer. Let's do another one, number 3. So first things first, we have to identify, there we go. We have y is greater than absolute value of x plus 1 plus 4. So our vertex is at negative 1, positive 4. So negative 1, positive 4. Then we plug them all in. If we plug in 0, 0 plus 1 gets you 1, 1 plus 4 gets you 5. Plug in 1, 1 plus 1 is 2, 2 plus 4 is 6. We plug in negative 2, negative 2 plus 1 is negative 1, negative 1, the absolute value of negative 1 is 1. 1 plus 4 gets you 5. Then I gotta plug in negative 3 into this x value. So negative 3 plus 1 gets you negative 2. The absolute value of negative 2 is 2. 2 plus 4 gets you 6. We then got to connect them up. So there's our absolute value equation. Now to deal with the inequality part, it says y is greater than. So it's greater. Now notice here, it's greater than, it's not greater than or equals to. I didn't catch that part in the other problems. I didn't really highlight it there. So greater than we know is above. So let's first deal with that. So we're going to shade above the absolute value there. Now, greater than, that refers to a dashed line. So these red lines I dragged in, right there, good. They're going to be dashed. So don't forget about those dashed lines. Let's see, in the previous problem it's supposed to be dashed also. So we could fix that. How about in the first one? Yep, in the first one too. Supposed to be dashed lines. There we go. Fixed. Alright, look at number 4. What you see is y is less than. Well, less than, you know, is to the left, but in this case, it's going to be a little bit different with absolute value. So it's less than, and we know it's going to be a dashed line. At x plus 2 absolute value, and then the plus 0. So your coordinates -2, 0. So -2, 0 is right there. Then, going from there, we plug in -1. -1 plus 2 gets you 1, +1, and +1, the absolute value of +1 is just 1. We plug in 0. 0 plus 2 is 2. The absolute value of 2 is 2. So you put a dot right there. Plug in -3. We get an output of 1. And we plug in -4. We get an output of 2. We connect them up. And there. And right here. And then we got a shade since this y is less than. You gotta ask yourself, are we shading above the line or are we shading up below? So we look at our y-intercept because it's referring to y, which is at 2. So where are the numbers that are below the number 2? Is it 3, 4, 5, or is it 1, 0, -1? Well, below, less than, that would be 1, 0, -1, -2, -3, -4. So it would be that side of the absolute value wall. So we're going to shade everything on that side of the absolute value wall. So I'm going to shade. In this case, I did blue. I'm going to shade that entire side. And then we also want to double check, do we have to have solid lines here? Or is it dashed lines? Well, since it's just less than, these are supposed to be dashed. So that would be your answer. Alright, just to let you know, on some of the problems, I'm going to just ask of you to shade the inequality, and the absolute value function will be already graphed. So don't be tricked or don't get nervous if something's already graphed there. Whether it be on SAT or ACT, it very well could be. They're just trying to help you out a little bit. Let's speed along the process. So, in this case, we have y is less than absolute value of x minus 1. We already see that this red line already is graphed. We know that less than, that means that's supposed to be a dashed line. So I'm just going to write dashed on the side here. This is supposed to be a dashed line. There and there. Now we got to determine, is it less than or greater than? Well, y is less than. So since it's less than, we got to shade below. Less than is below. It's below that -1, so we got to shade below our picture. Wow, I'm not asking perfection of shading here. We'll get the general idea. When you shade below, like that. Number 6, y is greater than. I'm actually going to make a little equals. This is going to be greater than or equals. Y is greater than or equal to absolute value of x minus 1 plus 2. Well, that means it's just this is a solid line. It's already graphed for you. Now we just got to do the shading part. We'll do a purple shade. So this is referring to the y. We look at 3. Numbers that are greater than 3 are above, so we shade above. And that's our work. So, classwork for today. We're going to do O55 CW1, graphing absolute value inequalities. your homework. This is going to be 055 HW1 graphing absolute value inequalities. If you have any questions, feel free to email me or come to Extra Help. I'll be happy to help you out. All right, have a good night.